Good morning, thank you. So today I am going to be talking about how to get started writing automated unit tests. A couple of things about what this talk is not. I'm going to talk a bit about some of the good things that automated testing can get you, but I'm not going to go into extended depth about all of the things. Plenty of people have talked about lots of that over the years. This isn't that. I'm also not going to be talking about other types of automated testing. So I'm not going to be talking about integration tests. I'm not going to be talking about functional tests. This is how to get started on one particular kind of testing. I'm also not going to be getting into more advanced strategies, or I'm not going to talk about how to handle network stuff, mock stubs, any of that kind of thing. And this also isn't an introduction to test-driven development. This is particularly for people who are, maybe development isn't the main thing that they do, but you have to write code sometimes, and no one has sat you down and talked about, okay, here's how it goes. So what I am going to cover. I'm going to spend some time on exploring the question of, if this thing is so great, if this is, industry best practice and all of that, why don't we actually do it? Or why don't we always do it consistently? Or why is it such a hard thing to get started with sometimes? I'm going to be coming at this from a harm reduction approach. Basically, the idea is, meet people where they are, and something is better than nothing. I want to get you from, I know the basic idea behind unit testing, to I can at least think about looking at some code and breaking it down enough to start writing some tests for it. And to do that, I am going to be actually writing some tests. And then I'll talk a bit about where to go next once you have gotten started. So I'm not going to spend a ton of time here, but testing is really cool. Like I am a big fan of testing, even smaller stuff or stuff where it seems maybe less, there's less of a point to it. The discipline of writing tests helps promote you get into these virtuous cycles where you're like, okay, I've been writing this thing. I can't really break it down to write a good test. How can I make it so it's a little bit more modular? How can I make it so that I can break it down into parts that are more easily testable and parts that I can maybe get to later or get some help with? And that'll make your code more modular. It'll make your code more easier to reuse. It can also help reduce debugging time. So even if you have just a partial bare bones test suite that mostly tests, are your types all lining up? Are you actually calling your functions correctly? Do you have random typos and variable names? At least those are kinds of bugs that you don't have to spend as much time hunting. It also reduces duplicated work. So if you run into some sort of weird corner case and you're like, okay, that's kind of weird. I don't know what I want to do with that, but we can at least write a test to document the funky behavior, even if it's not something that you necessarily want to do anything with, at least if it shows up again for future you or for one of your coworkers. You have a starting point to say, okay, we've seen this before, sure is weird. And on that note, it's also free documentation. So even if you're not really, you don't have time, or you just have to get through, and you're like, okay, well, I don't have time to write good docs and to test and to do everything that I know that I really ought to be doing. At least if you have a suite of tests that calls your functions, you have some documentation in the tests on what it looks like to call that function. So it's pretty cool. Why don't we do it? Part of the reason why I didn't want to spend a ton of time trying to talk it up is because I think that sometimes, especially with the sorts of things that people know that they ought to be doing, adding the pressure on the one side to just do it doesn't necessarily help actually do it. So sometimes it's more effective to look at the barriers and try to bring down the wall that's between, that's keeping that pressure to actually do the thing that you're supposed to be doing, keeping you from getting to the other side. So some of these may resonate, some of these may not. You write a script, you're like, okay, I know I should do this, it can't be that hard. And then you start looking and you're like, I don't even know what kind of framework to use. A lot of people on the internet have a lot of opinions about this, and where do I go? Then sometimes you hit stuff in your code where you just don't know how to handle it, and so you can hit that for network stuff. Like if you have a function that's talking to an API, you're like, do I need a mock or a stub, or what's the difference, or patch or fake? And at some point, okay, I wrote this, but I don't know whether this is actually testing the thing that I want to, and it's easy to find something else to do. And sometimes the pressure comes from other people. So, as with all of these things that are best practices, people, it is, as a developer, I really enjoy working on code that is well tested, that I can relax a little bit and worry less about breaking things. And when I don't have that sort of certainty and guardrails, it gets frustrating. And it's easy for that kind of frustration to come out in, blame and shame, instead of, hey, thank you for your contribution, can we work together to get this tested? It's, why would you even bother? Or, what do you mean you've never done test-driven development? What kind of, agile person are you? So that's not particularly helpful when it comes to getting over that wall to actually test. And sometimes, sometimes the resources that you have just aren't at the level where you're at, or don't really apply. So if you're looking and what you've found is you found a bunch of stuff on test-driven development, and you're not even mostly, your job is not focused on development work, then that's going to be potentially super intimidating. And, we're busy. There's a lot of stuff that goes on. You sit down, you're going to start to learn something challenging for you, and then the pager goes off and your focus is shot, and it's really easy to just not come back. And then there's the one-time use scripts that 6 months later turn into part of your production ecosystem, and no one has, it just never came up, and it never came up as something to come back to. And all of these are really, these are things that happen, right? These are understandable. So I want to go off on a bit of a tangent here. Harm reduction is a concept from public health that I find very useful when it comes to thinking about people not doing the sorts of things that I really want them to, or I really think they ought to do. And the best way I can summarize it is people have reasons for what they do. You may not like the reasons, you may not think they're good reasons, but people do have reasons for it. And it's more respectful and more effective to meet them where they're at and to offer them resources for making the changes that they want to make. And you'll note this also involves talking to them about the changes that they want to make. And in public health, it's been applied to some of the more stigmatized and riskier decisions, and it's been found to be more effective than, abstinence-based or shaming-based, or like, well, you know better because that doesn't approach the reasons why people don't do the things that they ought to do. So, changing gears a bit back to the very basics of unit tests. The basic idea behind a unit test is that you find a unit of code, generally a function. You feed it some inputs. You control those inputs that you feed it. And you see, okay, this gives me outputs when I give it inputs. And then the documentation part and the automated part is that you write down those outputs and you test when you make changes to your code, do those outputs change? And if they change, is that something that I wanted to change, and then I should change the tests and write a new expected output? Or is that something where that is not behavior that I wanted to be different? That sounds simple. But when it comes to actually writing tests, you can break it down into a handful, like a bunch of sort of sub-skills that go into figuring out what tests you need. So one of the first thing here, write code that isolates side effects or network interactions. That gets back to what I was talking about at the first part, where you get that virtuous cycle where, writing testable code is going to make it easier for you to write tests. There's also the skill of finding the parts of your code that are easier to work with. So thinking about, okay, this is pretty self-contained. This talks to the, this talks to the network. This needs terminal input. And those parts are going to be harder to test. The self-contained ones are going to be where I'm going to suggest that you start. There's also figuring out useful inputs to test with. A lot of people have done some really cool stuff on this with property testing and stuff like that, where it just throws a bunch of stuff at your code, and it helps you figure out what's useful. That's way beyond what I'm talking about here, but there is cool stuff there if you want to look it up. And also, like writing tests that actually test what you want to test. Sounds a bit tautological, but especially when you start writing fake inputs and stuff like that, sometimes it's like, okay, how am I actually testing that the code is doing something here, or is my test tautological? So here is where I suggest you start. Write tests that document what your code does now. So I've heard those called pinning tests. Code has bugs. That is a fact of life. The thing here is that it's better to know where those bugs are and what those bugs do, and then you can fix those bugs and know that you're fixing those bugs and not, fix them accidentally or have them just be out there somewhere. I'm really going to hammer under just start somewhere. Even just getting tests set up, like finding a framework, getting it so that you have a couple of tests that will run, that is so much easier to move forward from than something that doesn't have any of it set up. As far as figuring out what tests to start writing, I suggest that you start with pure functions, and if you don't know what those are, that's where you really look at what the function itself is doing. So a pure function is one input leads to one and only one output. So that means that you're not handling I/O, that means you're not writing to disks, you're not handing out API calls that can come back with anything that the server wants, you're not messing with global variables, you don't have side effects. And then when it comes to writing the tests, give the function some inputs, figure out what outputs they give you now, and write it down. So, okay, here's the part where we're going to actually start writing some tests. So I've written a sort of fake interactive wrapper script. I've used similar, much better written scripts for. Oops, that size was not where I want it to be. I've used similar wrapper scripts for, you know, the sorts of tools where the interface is just like there's a whole bunch of flags that need to be set. Can't always remember all of them, and it's easier to just it's easier to have something programmatically build that for you before you run it yourself. So we're gonna pretend that this was written on some kind of deadline. Was nice enough to put a help script in there. So there's this entirely fictional program. YOY probably supports something vital or something. You know, there's a couple of arguments we could use. So let's see what it does. It's not an emergency right now. And so it gives some instructions for running the command. You know, tells you what system you're working on, has an argument that I'm sure is there for very good historical reasons, has that one argument that you always forget to set, and the user. So let's take a look at the code for this. I'm going to scroll down to where the main part of it is. So yeah, Python gives you nice ways to set up the argument parser, and it gets the nice help thing. There are a couple of functions here. So I've split out getting the input. You know, the interactive stuff that I was showing you here. So that's this get input values function. And then there's the build command function that mostly just does some string concatenation, a little bit of if else control flow, and from there it returns the command that you want to run, gives you some instruction text, and prints it out. So let's, I'll briefly just say the get inputs value function is there. We are not going to start with testing this because that would involve faking out the command line input, and that's more work than we want to deal with right now. But what we do want to work on here is this build command function. So it takes the host name, it takes whether it's urgent or not, that's going to be true or false, and it takes the user argument. There are two paths it could take. If urgent is true, then it will set the panic flag. If not, then nothing. And it really just formats the string, taking the inputs to the function and putting those into the stuff that you forget or are likely to mess up. So let's see. I'm going to switch these two actually so that y'all can see a little bit better. The test framework that I'm using for Python is PyTest. I really like that. I think it's a pretty good starting point if that's what you are, if that's the language that you're working in. I have a test file here. It doesn't currently have tests in it. So PyTest looks at that and it's like, nothing for me to do. So importing PyTest, importing the function that I'm going to be testing here. So the basic process that I'm going to do is I'm going to pick some reasonable inputs. I am going to feed them to build command and see what it gets me. And then I'm going to say, OK, that's what you do now. Cool. And then I will turn that failing test into a passing test. And I'm totally going to remember my syntax here. So what I've done here, this is a starting point, not an ending point. I am calling. I'm saying, okay, so hostname truth, urgent true, and user it me, and I am deliberately writing a failing test to start with because it's one of the easier ways using this framework to get it to print out the output of the build command. So I see, okay, it's called this. This is what that output is, and I am asserting that it is false, which is obviously a failing test. That means that I can, oof, that was not what I wanted to do there. Okay. And I'm just going to argue with Python for a little bit on string concatenation here. Excuse me. All right. I think that oh, except we still have output equals false, and instead we want to check that that output equals expected. And it passes. So what we've done here is we've tested one path through this code. We've passed in urgent equals true, so we have set the panic flag. Otherwise, that means that as far as this test suite is concerned, this else could be doing anything, and the test suite doesn't say anything about that behavior because we haven't tested that logic branch of the code. But we do now know what it does if we pass in urgent equals true. So that is our first test. Go us. Now I'm going to test the second path here, the one with where it's not urgent. And you note I'm using fairly verbose names. I'm doing that for a reason. It's because it'll, most test frameworks will tell you the name of the failing test, and that's free documentation. And we expect this to fail, which it does. One pass, one fail. And again, we hope that string concatenation actually works like that. No. Oh, okay, so I think, oh, because I actually pasted the thing from the last time. Okay, that's, so this is, there, basically, there's all sorts of ways that, typos or what have you will just chasing that down. Sometimes it's a problem in the test, sometimes it's a problem in your code. I do suggest, if you find that it's a problem in your code, write the test for the current behavior and then deliberately go change your code. But that's not always possible. So if I were running a coverage tool, this would now be fully covered because we have one test that goes through the, if urgent is true branch. We have another test that goes through the if urgent is false branch. They both pass. So one of the things that trips some people up sometimes is what happens if you expect an error to happen? Does that mean that you want your test suite to throw an error? It doesn't. You want all of your tests to pass. A failing test means that the code is not doing what you expect it to, not that the code is throwing an error. An expected error is a passing test, and frameworks are going to have ways to mark expected errors. So let's go do one of those. So you forgot to pass in the the panic flag for some reason. Or maybe you were using this somewhere else in the code and hadn't seen that this bit had been changed, and you were expecting it to still have 2 arguments, and that's just not what's going to happen. So using the same structure as we used last time. This test still fails, but it doesn't actually fail because of an assertion error. It doesn't even get to the assertion because when you call build command with only 2 arguments, it's missing one of the required arguments. It gives you a type error. So we're going to delete that assertion because it's not relevant. And this doesn't need to be assigned either, because what we care is that when we call this, the test framework knows that it is not supposed to work. So the syntax for that on PyTest is with pytest.raises. I think that's it. Oops. Let's see what that does. And that passes. So, and the reason it passes is because we told it the kind of error that we expected. If we were calling it with, I don't know, let's say we were passing in a byte string there. I'm pretty sure that would give you. Oh, it's still a type error. So this actually is not a great example to show the difference. It's just that this type error might be a slightly different one. So let's go back to the expected sort of error here. So what have we done here? We have looked at we've looked at the script. We've figured out this is going to be the part that's going to be a pain. I'm not super comfortable with testing. I'm not going to start here. We found this one, though, where pure function, 1 input, 1 output. If you feed it the same set of strings, it's always going to put them together in the same order, in the same everything, and it's going to give you 1 big string. And we've taken that, we've fed it a couple of expected normal kinds of inputs to go through all of the paths. And we've also looked at expected kinds of failures for this function and written a test to document that. Yeah, this is pretty much what I just said there. So sort through the code. I cheated a little bit with having the testing framework all ready to set up, but that is one step that you'll go through. Write tests that fail, give the tests the reasonable inputs, and have the tests document what the code does now. So if there's a typo in that, I don't care. I mean, I do care. I want that fixed. But I'm going to write my test first so that when I fix that typo, I fix it on purpose and I know I'm fixing it. Okay, so you've gotten this far. You've gotten to the point where you're relatively comfortable setting up a test framework. That can be its own skill, actually. So if that's something that you're struggling with, like just getting the project structure set up so that the tests run and the framework can find the tests and stuff like that, that's not just you. That can be challenging. Recommend you find someone, like either look for resources or find someone who's done it before and who can help you with that step of it. So you've got that set up. You're feeling fairly comfortable with testing pure functions. Where do you go from there? So practice it. That's the first thing. This sort of thing gets easier with practice, and it gets easier to go back through your code and to refactor so that you start with the easy stuff, and then there's more easy stuff, and then life is sunshine and rainbows, or at least well-tested code bases. And then start gearing up for the harder stuff. So this automated testing is often the sort of thing that people sort of learn by working on projects or working with people. So read code and read how, if you have a project that you like to work on, see how the tests are set up for that. You can also pair with other folks, but when you do that, make sure that your goals line up. So if your goal for pairing is to learn how tests go and learn how all of that works, and your partner's goal is to get the code written as fast as possible, that's probably not a very good match. So communicate, basically. And once you have a handle on the more basic stuff, start looking into those more advanced testing resources. So start playing around with faking out endpoints. If you have a code base that is pretty substantial and you want to learn how to test it, working effectively with legacy code is still a classic and has some strategies for just like getting tests written. And you can kind of gamify some of this. There's code coverage tools that will, even if you're starting from like 10% coverage, you can say, okay, well, new code is going to have tests, or, well, okay, but I'm going to keep on getting that up there. 100% coverage is not necessarily the most useful thing to shoot for. Just putting that out there, like it doesn't have to be all the way up there, but aiming to increase is like aiming to increase, and within that, making sure that the tests that you write make sense and are actually testing what you want to test can be super useful. Okay, so I would like to thank you all for your time and attention. I would also like to thank the folks I was working with at the Seattle ADEC some years back, especially Kim Wellmark, whose thoughts on this were very useful when I was gearing up and getting started on testing myself. I am happy to chat with people in the hall or after the session, and thank you again.